So same EQ as yesterday. We have our quiz over SigFigs tomorrow. On Tuesday, y'all will have a test over SigFigs and the unit that we're going to start today. It's a measurement of matter, and it's all actually stuff y'all have already done. And then on Wednesday is when you'll have your journal test. So you'll need to have your journal with you on Wednesday. All right, I guess Rodney is not here. Didn't miss Rodney, did I? All right, so on these different little prefixes, because these prefixes are used in the metric system, which we actually probably won't get to until tomorrow. What does deci mean? And please just unmic and say what it means. Chat room takes too long.
One. It says, I think it says one.
So what does the prefix deci mean?
Like, I think it has to do with singular.
No, it doesn't. Think of like decade.
Oh yeah, 10.
10, exactly. Perfect. What about centi?
100.
100. What about
Number
milli?
3 is million. Million.
Not a million, it sounds like it, but it's actually 1,000.
Okay.
And what about kilo?
I think a million is like what I said earlier.
No, kilo is also 1,000. Kilo, when you put the prefix kilo in front of something like grams, those are very large. When you put the milli in front of something like grams, those are very small. So it would take like 1,000 milligrams to equal 1 gram, or 1,000 grams to equal 1 kilogram. So they both mean 1,000 in the metric, but they're just, one of them's very small and one of them's larger. All right, I'm gonna go in and do my attendance real quick. So if y'all will just open up your notes, they're in your all right, starting off with scientific method. The scientific method is a logical approach to solving problems by collecting data. Oh, that should go over here. Observing. So that's usually done through experimentation, formulating and testing hypotheses, and then finally formulating theories that are supported by the data that you've collected. So to begin with, the scientist usually does some background work with them, observation. That involves making measurements, and collecting data. And if you remember from biology, data may be one of two types. If it's just descriptive, data is qualitative, Qualitive, or if it's numerical, then it's going to be quantitative, Quantitative. And in chemistry, we really deal with quantitative more than we do with qualitative. Experiments involve carrying out a procedure under controlled circumstances. Remember, you talk about a controlled experiment where you're testing only one variable at a time, and usually there's a control you have to compare it back to. So before the experimentation begins, the scientists will formulate a hypothesis, generalizations, or statements that apply to a range of data. Generalization, so I'm just going to put little ditto marks because it's the same word goes there, are used to form a hypothesis, which is a testable statement. Often used as an if-then statement. If I feed the tomatoes fertilizer, they will grow bigger. If I give my students lots of pop tests, pop quizzes, they will do better. So after they've formulated the hypothesis, and they're going to have to test it. So experimentation is used to either support or reject a hypothesis. And oftentimes it is a rejection. Theories can be formulated after hypotheses have been proven, and theories are based off of several hypotheses that are kind of in the same field. So like cell theory, that would be an example. And they come and they end up forming a model, which is an explanation of how phenomenon occur and how data of events are related. So like I said, that's just a real quick scientific method. Y'all had that last year. You'll probably see it on your test next week. You'll probably see a couple of questions from that. So what we really want to cover more is units and measurements, because that's kind of what becomes important. So a quantity is something that has size, magnitude, or amount. It is not the same as a measurement. So a quantity may be used in math, but in science we use measurements instead. So those are going to be numbers with units, so it tells us what the quantity applies to. So it has a little bit more meaning. The SI system stands for System International. It was adopted in 1960 in the scientific world. We don't use it in our everyday life. And the SI system has standards which are set up, and they have a constant value. So then other things can be compared around them. All right, so we're going to look at some base units. Remember, what makes a metric system, supposedly what makes it easy to use, although we're not used to using it, is that everything is based off a power of 10. So in other words, if I'm going to do a conversion, I'm just moving my decimal. Unlike with the English system, if I want to do some type of conversion, excuse me, I'm going to be moving my decimal, but I'm also going to have to be multiplying, dividing by some kind of number, sometimes subtracting. So it becomes a little bit more trouble. All right, so if we start with length, the symbol is L. Meter is the base unit name. Abbreviation is a big M. For mass, we have little m. Kilogram is the base unit. kg. Time is a little t. Second is the base unit, little s. Temperature, big T. Kelvin. Kelvin does not have a degree sign. Let me spell that down here since it's kind of Kelvin without a degree sign. It's not like degrees Celsius or degrees Fahrenheit. Abbreviation to big K. Amount, little n, which stands for moles. MOL is abbreviation. Electrical current, capital I. Ampere. Or amp. And then luminosity intensity, IV. Candela. CD would be the abbreviation. All right, and then we have what are called derived units. Derived units are a combination of units because you've either done a multiplication or a division. And so if you multiply or divide the number, you have to also multiply or divide the unit. So for area, you're multiplying two numbers that have units with them. So I end up with a square meter or meter squared. Volume is length times width times height. So I end up with a cubic meter or a meter cubed. Molar mass, grams per mole. There's my abbreviation. Another one is density. Density is mass divided by volume. So our units could be grams, they could be kilograms over milliliters or liters, cubic centimeters, anything that's a volume. If you have some type of ratio of a mass to volume, then you're going to have those derived units of mass over volume. So mass is defined as the quantity of matter of an object. Weight weight is a mass of an object multiplied by the gravitational pull. Well, a little technical difficulty there. So that's why if you went to the moon, your mass would be the same, but your weight would change because the gravity changes. Length measures the distance in one plane of an object. Volume is the amount of space occupied by the object. The SI standard is a cubic meter, but that's usually really pretty large and too large to work with for convenience, especially in chemistry. So we tend to use, instead of the cubic meter, we tend to use the cubic centimeter. Centimeter cubed. And another name for that is cc. cc stands for cubic centimeter. The non-SI base unit is the liter. It has a volume of a decimeter, deciliter, or deciliter cubed. This is an important relationship right here that comes into play a lot. 1 cc is equal to 1 ml, and so the two are interchangeable. If I have 100 cc's and I have 100 mLs. Oftentimes for animals, like medicine and stuff, is measured in cc's, but then with the humans, it's usually measured in milliliters for some reason. All right. So density, we're going to talk about density for a little bit, maybe. I know y'all have done density problems before, but now you have to remember anytime you do a problem like this and we're basing it off of a measurement, which is how it would be with density, you have to take into effect or take into account the sig figs whenever you get your answer. So density is a ratio of mass. I'm on a little calculator, a little computer. Oh, I know my pen, maybe. Let's see. Hold on, people. I'm having a little. Let me see. I'm gonna have to change tools real quick. I think my pen died. Hold on one sec. All right. Let's see if I can get this underneath the overhead. All right, so we'll move to this. So density is a ratio of mass to volume. And the equation is density is equal to mass divided by volume. It's one of the ones that will go into a triangle. In case you like that, it kind of helps you rearrange. Remember, mass would have units like grams or kilograms or milligrams. And then volume would have units like milliliters or liters, maybe centimeters cubed or cc. And it's kind of important to know that when you're doing your problem. Density is mostly expressed in the units gram per milliliter, but it could be any unit of mass per volume. So, I mean, I could have kilograms per liter. Anytime I have a mass divided by a volume derived unit, then that could be for density. All right, so we'll just look at a couple of practice problems. It says, what is the density of a block of marble that has a mass of 853 grams and a volume of 310 grams? So I'm going to fill in my formula. Density is equal to mass divided by my volume. Pretty easy. And then I'm going to notice that this has 3 sig figs and 310 only has 2 sig figs. I'm dividing. So when I get my answer, I can only have 2 sig figs. So while I might get something like 2.75 in my calculator, that has 3 sig figs. So I would have to make an adjustment. 2.8 would be my correct answer. And then my units are grams per cc. So the math is just like you've been doing, but now when you get your answer in your calculator, you have to look at that answer and then you have to adjust for sig figs. The next one says mass of a 0.350 diamond, and here's my density. So if I come over and I use my little triangle, if I cover up my M, then I see I need to do density times volume. So my volume has 3 sig figs, and so does my density, so my answer should have 3 sig figs. .26 times 0.350. So pretty easy multiplication. I just put in my calculator, 1.14. That's my 3 sig figs. CC's cancel, and my unit I'm left with is grams. All right, I'm going to give y'all a minute to try the next one on your own. All righty, if we start with A, I can't really do this very well. A, grams per milliliter, that would be density because it's mass per volume. What would B be? S.
Time.
Time, yes. What about KM?
Length.
So that's length, exactly. What about G?
Mass.
Mass, perfect. What about centimeter cubed?
Density.
Length.
A centimeter cubed can be part of density, but it would have to have another unit with it. Centimeter cubed is the same thing as a cc. Does that help any?
Volume.
Volume, yes. What about mm for a millimeter? Millimeter.
Length.
Length.
Yeah, length. And G is liter. Think of what you buy. If you get 2 liters of Coke, what is it telling you? It's how much, it's what?
Volume.
Volume. And then the last one is grams per centimeter cube. So that would be like A. It's a mass divided by volume. So that would be density again. All right. We're going to stop there in our notes. You see what we have coming up? Conversions, where you're just moving your decimal. Going over scientific notation, which I know y'all have had before, so just refreshing your memory. And then some temperature conversions. That's what we have left on this unit. So hopefully none of it will be too hard for you. So tomorrow we'll start off with the significant figure quiz, and then we'll hopefully get through these notes, and then I'll have some practice set up that covers all the rest of this to kind of help you get prepared for the test on Tuesday. Does anybody have any questions or need anything? All right, if y'all got a few minutes before your next class, you can hop off and maybe work on your sig fig practice online if you want to. And I shall see y'all tomorrow. It'll be Friday. Y'all have a good one.
Miss Lowry,
Yes.
could you go back to the SI base units, that chart with the
Yes, I
abbreviation?
surely can. Yes, ma'am. Yes, ma'am. That one?
Yes.
Okay.
Thank you.
You're very welcome. See you tomorrow.